I just want to tell you that your unit 2 is actually differential calculus, and integration is basically the inverse process of differentiation. So what are all formulas you have learned in the derivatives? So using those formulas, you will be having formulas under integration. This is the first thing. The second thing is integrals are broadly classified into two types. One is known as indefinite integrals and another one is known as definite integrals. Indefinite integrals are nothing but integrals without limits, and definite integrals are integrals with limits. So in the case of indefinite integrals, when you integrate, you will be getting a constant of integration. Whereas in the case of definite integrals, since there are limits, when you integrate, you have, even though if you have a constant of integration, it gets cancelled and therefore there won't be any constants, right? So first, let us move on the standard results under integration. So you are familiar with the standard results under differentiation. So from the derivative formulas only, we have got all these integral formulas. So to start with, we just look on the left-hand side of the slide. So you have a set of formulas, namely integral x power n dx is x power n plus 1 by n plus 1. That is the most basic and the standard formula in integration. Then of course you have 1 by x dx equals log x. You know that derivative of log x is 1 by x, and hence we are getting integral of 1 by x is log x. Then integral of e power x is e power x. After that you have the integration of all the trigonometric functions, namely integral of sin x, which is minus cos x, integral of cos x, which is sin x, integral of tan x, which is log secant x or minus log cos x, then integral cosecant x, which is log of cosecant x minus cot x, then integral secant x, which is log of secant x plus tan x, and integral cot x is equal to log of sin x. So apart from these standard integration formulas under trigonometric function, based on the derivative formulas, namely differentiation of secant x, you know that it is secant x tan x. Based on that, you have integral of secant x tan x dx is equal to secant x. Similarly, derivative of cosecant x is minus cosecant cot x will imply integral of cosecant x cot x is equal to minus cosecant x. As I told you, integration is the inverse of differentiation. Similarly, derivative of tan x is secant square x implies integral of secant square x is tan x, and derivative of cot x is minus cosecant square x implies integral of cosecant square x is equal to minus cot x. So these are some of the standard formulas under integration. So now we'll go back to the integral formulas, which you see on the right hand side of your slide. So they are exactly similar to what I have written on the left hand side, except for a difference here is x is being replaced by ax plus b. So take the first one. What you have there, ax plus b the whole power n dx is what you have. It is exactly of the form x power n dx. Therefore, you can very well apply the same formula. So when I apply the formula, you'll be getting it as ax plus b the whole power n plus 1 by n plus 1. But since you have a coefficient for x there, you have to divide the coefficient, that is the term, by a. In the case of differentiation, when you have a coefficient of x, you multiply by a. Therefore, in the case of integration, you have to divide by a, which is the coefficient of x. So I have given you the corresponding formulas on the right hand side for all the formulas that appears on the left hand side. So already we have discussed these formulas. So apart from these set of formulas, we have another set of 9 formulas, which are also equally important. Take the first 3, which involves the functions a square minus x square minus a square, and a square plus x square. And integral of dx by a square minus x square is 1 by 2a log of a plus x by a minus x. Integral of dx by x square minus a square is 1 by 2a log of x minus a by x plus a. And integral dx by a square plus x square is 1 by a tan inverse of x by a. Then towards the right, you have another 3 set of formulas, which involves the same functions, a square minus x square minus a square, x square plus a square, but with a square root, and it appears in the denominator. Also, we have other set of 3 formulas with square root of the same functions. So all these 9 formulas are also equally important. So with these standard formulas keeping in mind, first let us see some of the problems where we directly use the formulas and do the integration. So these are some of the examples where we do the integration directly applying the standard results. So take the first problem. What do you have in the first problem? 4x power 6 minus 1 by 8x cubed plus e power x plus 12 minus root of x power 7 plus 2 by x. So most of the terms are of the form x power n, whose integration is x power n plus 1 by n plus 1. So 4x power 6 integration is 4x plus 1 by 7. 1 by 8x cube is nothing but 1 by 8 of x power minus 3, which is also of the form x power n. Therefore, its integration is x power minus 2 by minus 2. Then, of course, integral of e power x is e power x. Integral of a constant is constant into x. Then, root of x power 7 is nothing but x power 7, the whole power half, which is nothing but x power 7 by 2. Again, it is of the form x power n. So, its value is x power n plus 1 by n plus 1. And of course, 2 by x is integral of 1 by x, which is log x. So you have 2 log x plus constant. Take the second one. Again, simple functions, direct functions, for which you have the formula ready-made. So integral of cos t, it's not always that you should have the variable x. You can also have any other variable. It can be t or z or theta, whatever it is. So integral cos t is going to be sin t. Then 4 by root of 1 minus t square. So already we have seen in the previous case, 1 by root of 1 minus t square is actually of the form 1 by root of a square minus x square, whose value is sine inverse of x by a. Where here in this problem, your a is 1. So you are getting it as sine inverse of your x is t by a is 1. So you have the answer as 4 times sine inverse of t. In the third problem, what you have is integral of secant of 1 minus t into tan of 1 minus t. Actually, this is of the form integral secant x into tan x. And the answer for that integral is, again, by the formula list, it is it is plus secant x. So here in the place of x, what I'm having is 1 minus t. So therefore, since coefficient of t is minus 1, I have to divide by minus 1. That's why you're getting an negative sign over there, which is minus secant of 1 minus t. Look at the next problem. What do I have is 3 by 1 plus 9x square. As when you look at 3 by 1 plus 9x square, it is actually is of the form 1 by a square plus x square. But instead of x square, what I'm having is 9x square. So I'm writing that 9x square as 3x the whole square. So now it has been brought to the form 1 by a square plus x square. And the value for 1 by a square plus x square is tan inverse of 1 by a tan inverse of x by a. So here, since a is 1, it is actually 3 times tan inverse of 3x. But then, since instead of x, we have 3x here, I have to divide by 3. And hence, we have 3 into 1 by 3 tan inverse of 3x, or it is simply tan inverse of 3x. So in a similar way, I'll take the next problem. What we have is dx by x square minus 2x minus 35. So when you look at the denominator, it is not of the form a square minus x square or x square minus a square or x square plus a square. So what can be done to bring it to the form is to express it as a perfect square. So since we have x square minus 2x, I can write x square minus 2x as x minus 1 the whole square minus 36. Because only that will give the term x square minus 2x minus 35. Now, this is of the form 1 by x square minus a square, where a is 6. So, using the formula 1 by x square minus a square, if you want, you can just go through it. 1 by x square minus a square is 1 by 2a log of x minus a by x plus a. So, using that formula, we have 6 into 1 by 2 times 6, which is 12 log of x. In the place of x, we have x minus 1 minus a is 6 by x minus 1 plus 6, which is 1 by 2 log of x minus 7 by x plus 5. Similarly, you can try out the sixth problem. So there also you do the same thing. We have to express it as a perfect square and then bring it to the standard form and then apply the standard form and then integrate. So Not all integrals you will be able to integrate it directly using the standard formulas. So which means there will be functions where those functions cannot be integrated by the direct application of the standard formulas. So what should be done is those functions has to be converted into the standard form by doing some procedure. So before that, I just want to mention one more thing is, if you want to integrate a function, it's not that always it will be in standard form. Sometimes the function will be in such a way that you have to simplify the function, or you have to make some adjustments and bring it to the standard form. So one of the examples is, you can just go to example number 8. In this, you have integral of square root of 1 plus sine 2x. So as such, you don't have a direct formula for integrating this function. So what we do is, we write 1 as sine square x plus cos square x, and sine 2x can be written as 2 sine x plus cos x. So these are the well-known trigonometric relation results, and which is nothing but square root of sine x plus cos x the whole square. When you take the square root, it becomes sine x plus cos x. Now it has been reduced to the standard form, for which you know the integral values, so which is minus cos x plus sine x. Similarly, in the next problem, you find out dx by 1 plus sine x, where you find out addition of terms in the denominator. Normally, when you have addition or subtraction of terms in the numerator, you can always split the integral and integrate. But when you have addition or subtraction of terms in the denominator, we cannot do so. So what you should do is, again, you have to make an adjustment. The adjustment done here is, you are multiplying and dividing by 1 minus sine x, which results in integral of 1 minus sine x by cos square x. Now you can split the integral as 1 by cos square minus sine by cos square, which is secant square minus secant x tan x. And integral of secant square x result is ready-made, which is tan x, and integral of secant x tan x is secant x. So we have done the integration and got the results. So always you cannot, the given function won't be in the standard form. So one thing is, you have to bring it to standard form by making use of some adjustments, or by making use of some relations, or else you have to use some method in order to reduce it to the standard form. So what are the methods that we are going to see? These are some of the integration techniques we are going to see in this chapter. That is integration by substitution, integration by partial fractions, integration by parts, and generalization of integration by parts, which is also called as Bernoulli's formula. So how do you know whether you want to do substitution or partial fractions or by parts and so on? So in most of the cases, in order to do substitution, the main trick is, inside the integral, that is the function that appears inside the integral, you can find two terms inside the integral, such a way that one term is going to be the derivative of the other. So if you find such a situation where in the two terms, if one term is the derivative of the other, then you can always try the integration by substitution method, do the substitution, try to reduce the original integral into an integral which is reduced to a form which is in the standard form, and then you can integrate that. So that is the first one we are going to see, integration by substitution. So look at the first problem. What do you have? Integral cos x by 1 plus sin x dx. So the function as such, I have told you, it is not in the standard form, so you cannot use the standard formulas directly and get the results. And also you find out that derivative of the denominator, namely 1 plus sin x, is equal to your numerator. So I am able to find out two terms where one term is the derivative of the other. So in such cases, you can always use the substitution procedure. So what is substitution you make here? Put 1 plus sin x as t, that will imply cos x dx is dt. So when you make the substitution, you have to transform everything into the new variable t. So the original integral takes the form integral dt divided by t. So now this is in the standard form, and what is the value for this integral? It is equal to log t. But since t is a new variable and I want the answer in terms of the old variable, I have to convert your t in terms of x. So I'm writing it as log of 1 plus sin x. Look at the second problem. We have integral e power tan inverse x by 1 plus x square. So again, here you find that derivative of tan inverse of x is 1 by 1 plus x square. So you're making a substitution. Tan inverse of x is equal to t, which implies 1 by 1 plus x squared dx is equal to dt. So the integral reduces to integral e power t dt, which is as simple as that, for which you can use the formula directly, and the answer is simply e power t. Then replace t as tan inverse x. So you'll be getting the answer. Third integral also very similar. You find that, see the denominator, what you have is x square plus 2x plus 2. When you differentiate x square plus 2x plus 2, what you will be getting? You will be getting 2x plus 2, which is nothing but twice of x plus 1. So what you find is, you are getting a relation between the denominator and numerator in terms of the derivative. So when you make the substitution as x square plus 2x plus 2 is equal to t, then your denominator becomes 2 times, whereas x plus 1 dx is dt by 2. And again, when I replace everything in terms of the new variable, this is what you get, dt by 2t cube. Again, 1 by t cube is nothing but t power minus 3, which is of the form t power n, and whose integration value is t power n plus 1 by n plus 1 is what I have done there. So it is minus 1 by 4t square. So after doing the integration, replace t back to x, which is x square plus 2x plus 2 the whole square. Sometimes there is a possibility that you have a square root term inside an integral. So whenever you find a term containing a square root inside the integral, which is not, of course, in the standard form, we normally tend to take the term inside the square root as t or t square. Both are applicable. So here actually I have taken x minus 2 as t. Then the remaining term, what do you have in the integral? I am having x square plus 1. So once I make a transformation, I have to change everything in terms of the new variable. So x minus 2 is equal to t will imply x is equal to t plus 2. So convert all the x's into t. What I will be getting is x square plus 1 becomes t square plus 4t plus 5. So I just replace that by t square plus 4t plus 5. And root of x minus 2 is root t. And what is your dx? Dx is also equal to dt. So when I just substitute that, and when I multiply everything, it reduces to the standard form again. So apply the formula, integrate. After the integration, replace t by x. So fifth problem is also the same, but fifth problem, what do you find out is, you are finding out root in both numerator and denominator. So you will have having a confusion as what you have to choose as your t. But then you find one more thing here is, the derivative of root x is actually 1 by 2 root x. So which means you find that there is a combination of two terms where one is the derivative of other. So I am going to take root x minus 1 as t. Therefore, 1 by 2 root x dx is going to be equal to dt. So again, as we have done earlier, just transform everything in terms of the new variable and then integrate it. After integration, replace it with respect to your x. So this is what you are doing in integration by substitution. So as I told you, the tip that is used in integration by substitution is see whether you can find out two terms where one is the derivative of the other. If so, then going for substitution. And again, when you have a function, it's not always that you have this combination of one being the derivative of the other. So which means I have to try out for some other option to integrate the given function. So the next option that we are going to see is integration by partial fractions. So what do you mean by partial fraction? Because going on to what do you mean by partial fractions? First of all, what is the form in which you can use the partial fractions? So the form is, if you have a form of a quotient of two functions, namely f of x and g of x, where both f of x and g of x are polynomial functions, under the condition that degree of f of x should be strictly less than degree of g of x, okay, then we can express this quotient f of x by g of x as addition or subtraction of simpler fractions. And this procedure of expressing f of x by g of x into simpler fractions is what you call as partial fractions, right? And how will you express this as partial fractions? In order to express this as partial fractions, we mainly concentrate on the denominator function g of x. So how should the denominator function g of x? Normally denominator function g of x will be product of some terms. So based on the type of product, we are going to split this function f of x by g of x as simpler fractions. The first type that we are going to see is that the denominator function g of x is the product of non-repeated linear factors. That is, you should have g of x as x minus a1 into x minus a2 into x minus a3 plus etc. up to x minus an. There is no factors repeated. Then how do you split this rational function? You split f of x by g of x as a constant by the first factor plus another constant by the second factor plus and so on. You continue this until how many factors you have. But then after doing this, you have to find out the unknown constants a1, a2, etc. up to a1. That is the procedure. That is the type 1. Now type 2 is your g of x. Again, as I told you, the procedure for splitting into partial fractions, it depends only upon the denominator function. So if g of x has a product of n repeated linear factors, say x minus a the whole power n, then you write f of x by g of x as constant by the first power, another constant by the second power till the power that you have in the expression. So an by x minus a the whole power n, where again the constants a1, a2, etc. up to an have to be determined. Next is type 3. Type 3 is actually your g of x consists of a quadratic expression. Quadratic expression where in the case of a quadratic expression, you can, it is not, we take a quadratic expression which cannot be factorized into linear factors. Cannot be factorized into linear factors. Say for example, g of x is equal to ax square plus bx plus c, which cannot be factorized into linear factors. Then I can write f of x by g of x as not constant by x square, but a linear form divided by x square plus bx plus c, where again here p and q have to be determined. The standard form of a quadratic equation which cannot be factorized is actually x square plus a square. So x square plus a square is one such quadratic expression which cannot be factorized into product of linear factors. Now we will see how to split into partial fractions based on 3 types. Some problems. Okay, so now we'll see the problems under partial fractions. Take the first problem. We have here 3x square plus 1 divided by x plus 1 into x minus 5 the whole square. So now look at the function as such. It cannot be integrated directly. So I cannot directly use the formula. Second thing is you cannot go in for substitution also, because one term is not the derivative of the other term. So you can also not do substitution. So next option that we can look for is integration by partial fractions. So look at the term in the denominator. As I told you, based on the terms in the denominator only, you're going to split into partial fractions. So what are the terms that you have in the denominator is x plus 1 into x minus 5 the whole square, which means you are having one non-repeated factor and two repeated factors. So it's basically a combination of type 1 and type 2. So type 1 is actually non-repeated linear factors and type 2 is repeated linear factors. So based on those two types, what we're going to do is I'm going to express that function f of x by g of x as a constant by the non-repeated linear factor, that is x plus 1 plus another constant by repeated term is x minus 5 the whole square. So the first power of repeated term is x minus 5 plus c by the x minus 5 the whole square. Then what you have to do is take the LCM. What is the LCM? LCM is nothing but x plus 1 into x minus 5 the whole square. So after taking the LCM, what you'll be having is a into x minus 5 the whole square plus b into x plus 1 x minus 5 plus c into x plus 1. Now just compare the last two ratios. You find that the denominators are equal. Therefore, the numerators have to be equal. So therefore, you'll be getting one expression, which is the 3x square plus 1 is equal to a into x minus 5 whole square plus b into x plus 1 into x minus 5 plus c into x plus 1. So what do you find here is our aim is next. Our aim is to find out the three unknowns, a, b, and c. For finding three unknowns, I need three equations. So how will you get those three equations? For getting those three equations, we can give any three values for x and obtain three equations and solve three equations and get the values of a, b, c. But when you do that way, it is going to be a bit lengthy procedure. So you have a shortcut method of giving specified values to x so that you will get the unknowns directly. So how will you give those specified values? For giving the specified values, you have to look for the linear factors that appear in the denominator. So what are the linear factors that appear in the denominator? One is x plus 1, another one is x minus 5. So since there are two linear factors in the denominator, you can substitute x as minus 1 and you can substitute x as plus 5. So when you substitute x as minus 1, you'll be getting one value ready-made. And when you put x as plus 5, you'll be getting the next value also quickly. So by putting x is equal to minus 1 on the previous equation, you'll be getting directly the value of a using the equation 4 equals 36a or a equals 1 by 9. Like that, putting x is equal to 5 on both sides, you'll be getting 76 is equal to 6c or c is equal to 76 by 6 or it is 38 by 3. So after having got two values, there is only one more value which is left unknown. Whenever there is only one value is unknown, you can always put by default x as 0. That is the easiest value. So I am putting x as 0 on both sides. So you'll be getting one more equation involving all the unknowns. Substitute the known values a and c, you'll be getting the value of b, which is 26 by 9. So after having find these values a, b, c, you substitute in the splitting. So what do you get? 3x square plus 1 by x plus 1 and x minus 5 the whole square. This actually is a by x plus 1 plus b by x plus x minus 5 plus c by x minus 5 the whole square becomes 1 by 9 times x plus 1 plus 26 by 9 times x minus 5 plus 38 by 3 times x minus 5 the whole square. Now what you do is, now you integrate this function on both sides. If you do that, you find that all the functions that are appearing on the right hand side are exactly in the standard form. So you can integrate it directly. Therefore, you'll be getting it as 1 by 9 log of x plus 1, 26 by 9 log of x minus 5, and 38 by 3. X minus 5 the whole power minus 2 is x minus 5 the whole power minus 1 by minus 1, which is minus 1 by x minus 5 plus. So we'll see one more problem on the partial fractions, which involves type 3. Again, look at this function. See the function, it cannot be integrated directly, you cannot go in for substitution. So the option is partial fractions because you have in the denominator product of a linear factor and a quadratic expression. What is the quadratic expression? It is x square plus 4, this is of the form x square plus a square. As I told you, x square plus a square is a quadratic expression which cannot be expressed as a product of two linear factors. So the rule or the type is first constant by the first linear factor, is x minus 6, plus, since x square plus 4 is a quadratic expression which cannot be factorized, I have to introduce bx plus c by x square plus 4. The same as the previous problem, we're taking the LCM. After taking LCM, compare the numerator on both sides. You'll be getting x square plus 2x plus 3 is equal to a into x square plus 4 plus bx plus c into x minus 6. So as I told you again, three unknowns here have to be calculated, a, b and c. For finding the three unknowns, what is the procedure? You have to look for the linear terms, linear factors, and from those linear factors you have to give values to x and get the unknowns directly. So here I am having only one linear factor, namely x minus 6. The only value that I can put for x is equal to 6. When I put x is equal to 6, I'll be getting the equation 51 is equal to 40 or a is equal to 51 by 40. Now, since two more are left, only one more is left means I told you can put x as 0. Since two more are left, what we are going to do is we are going to equate the coefficient of the highest degree term on both sides. That is another way of getting an equation. So when I equate the coefficient of x square on both sides, this side, left hand side, the coefficient of x square is 1. Right hand side, the coefficients of x square are, one is a, another one is b. So that is what you have, a plus b is equal to 1. From there you can find out b by substituting a, it is minus 11 by 40, and we got two values now, only one more is left. So as usual, put x as 0, you'll be getting another equation which is 4a minus 6 is equal to 3. Put a value, you'll be getting the value of c. So after finding all these a, b, c values, substitute in the splitting. X square plus 2x plus 3 by x minus 6 into x square plus 4 is a by x minus 6 plus bx plus c by x square plus 4, which is 51 by 40 x minus 6 plus minus 11 by 40 into x plus 7 by 20 by x square plus 4. Now integrate both sides. First integral is the direct formula, so you'll be getting the answer directly, 51 by 40 times log of x minus x. When you take the second one, I have to split into two integrals as minus 11 by 40 integral x by x square plus 4. The next one is 7 by 20 integral dx by x square plus 4. Now in the second integral, you find that it is not in the standard form, but your denominator is the derivative of your, numerator is the derivative of denominator. So by using the substitution procedure, you'll be getting the answer as half log of x square plus 4. So that combined with 11 by 40 will give you 11 by 80 times log of x square plus 4. And the third one is actually, it is in the standard form. What is the standard form? Dx by a square plus x square, where a is 2, and the answer is 1 by 2 tan inverse of x by 2. So 7 by 20 into 1 by 2 becomes 7 by 40 tan inverse of x by 2 plus c. So we have, what are the methods that we have seen here is, first one is when you have a function which can be directly integrated, integrate it directly and get the result. If direct integration is not possible, see whether it is, you can go in for substitution. If substitution is it can be allowed, means do substitution, reduce it to the direct form and then integrate. That is the second procedure. Third one, when you have a function in a prescribed form, namely f of x by g of x, where g of x is the product of linear factors, then split into partial fractions and then reduce it into your standard form, then integrate and get the result. Then apart from all these three categories, if you have a function which cannot be done by any of these three categories, then we have the next formula, where you have product of functions, which is known as integration by parts. So what is integration by parts? So we apply integration by parts when you have product of functions inside the integral, which does not come under any of the categories which we have discussed earlier. And the formula goes like this: integral u dv is equal to uv minus integral v du. So we find that if I want to find the value of an integral on the left hand side, we have to integrate integral on the right hand side. So what does that imply? It implies that the integral that appears on the right hand side should be simpler than the integral that appears on your left hand side. So if I want the right hand side integral to be simpler, I have to choose u and v in a proper manner. So how do you choose u and v? So the choice of u depends on one rule called as the Eilert rule, where here I stands for inverse function, L stands for the logarithmic function, A for algebraic or arithmetic or polynomial, whatever you want, you can call it. T stands for trigonometric function and E stands for exponential function. So just follow this order. Based on this hierarchy rule, you have to choose your u and then you have to fix your v, right? So we will see how to apply this formula in that problem. So look at this problem. First problem is find integral log x dx. So integral log x as such does not have any direct formula. It can also be not done by any substitution method or by partial fraction method. So I'm going to solve this by the help of integration by parts. So what is the formula of integration by parts? Once again, it is integral u dv. So your integral should be of the form integral u dv. So here I am having only one function. I don't have many functions. Since I am having only one function, the only option is u has to be my log x. If I choose u as log x, what is the rest? The rest is dx. So that I'm going to choose as dv. So once you choose your u and dv, what else is that you have to find out? You have to find out v and du. So that is what I have done in this. What is my du? Du is 1 by x dx. And what is my v? V is nothing but integral of dv, which is x. So as per the formula of integration by parts, integral u dv is u into v minus integral v dv. So based on that, I am writing u is x, u is log x, v is x. So u into v is x log x minus integral v is x into du, 1 by x dx. So what happens now? You look at the second integral, that is the integral on the right hand side. What happens? It becomes a very simplified integral which can be integrated easily. So integral of log x dx is x log x minus integral dx, which is equal to your x. And then we always put that constant of integration as it is an indefinite integral, right? Now you have another formula, a different problem. Take this problem, integral of x sine inverse x by square root of 1 minus x square dx. Again, you are having product of functions, so it cannot be integrated directly because you would have that formula, substitution. Then you have, of course, substitution. But look at the function here inside the integral. You find that derivative of sine inverse x is actually 1 by root of 1 minus x square. So, since I am able to find out two terms where one is the derivative of the other, I can think of substitution method so that the function can be simplified. This is one of the methods I'm going to discuss. So I'm going to make a substitution. T is equal to sine inverse x, which implies dt is equal to 1 by square root of 1 minus x square dx. So the integral, the original integral now reduces to integral of sine t dt. So by substitution also, you find that the integral is not reducing to a standard form, but it is reducing to some other form. Now what is it, some other form? T into sine t. Now how will I integrate this t into sine t? I don't have a direct formula. Again, I cannot go in for substitution. I cannot use partial fractions. So how can I solve this? I can solve this only by means of integration by parts. So I am having product of two functions. What are the functions do I have there? One is t, another one is sine t. So since I am having two functions, I have to make the option of what I have to choose as my u. So as per the Eilert rule, which comes first, t and sine t means algebraic comes ahead of trigonometric function, and so I'm choosing u as t. Therefore, the rest is dv. What is the rest? dv is sine t dt. What I have to find out from this? I have to find out du and I have to find out v. What is du? du is dt. And what is v? v is minus cos t. And now I'm going to apply the formula for integration by parts, which is integral u dv is uv minus integral v du, which is integral t sine t dt is minus u into v. That is t cos t minus integral v. v is minus cos t dt. So what you'll be getting is minus t cos t plus t sine t plus c. So I have finished the integration, but then my answer is not in x, it is in terms of t. So what should be done is, I have to convert, or I have to give the answer in terms of x. You know that sine inverse x is equal to t. So what does that imply? That implies x is equal to sine t. So x is equal to sine t will imply cos t equals square root of 1 minus sine square. It is nothing but square root of 1 minus x square. So therefore, integral of t sine t dt is nothing but integral of x sine inverse of x by square root of 1 minus x square dx is equal to minus sine inverse x into root of 1 minus x square plus sine t is x plus c. So I'm just transforming everything in terms of x, and finally I'm giving you the answer. So this is your integration by parts. Now you have one more thing which is known as Bernoulli's formula, which is nothing but the generalization of integration by parts. So what do you mean by generalization of integration by parts? If you're going to apply integration by parts more than once, that is known as Bernoulli's formula. And the formula goes like this. The formula is integral u dv is uv, that is the first term. Instead of integral v du, we are having these many terms. What are they? Minus u dash v1 plus u double dash v2 minus u triple dash v3 and so on. What are those dash? Those dash denotes differentiation, and v1 is integral of v, v2 is integral of v1, v3 is integral of v2 and so on. So we apply this Bernoulli's formula mainly for the case when I have algebraic function as one of the terms in the product in the given function. Yes, if algebraic function appears in the product, then we normally apply Bernoulli's formula, because for an algebraic function, derivatives becomes 0 after a finite number of steps. So we just see just one example based on this Bernoulli's formula. And the problem is the integral x square e power x dx is the problem. So here, what functions I have here? I'm having two functions. One is x square, another one is e power x. Where x square is a polynomial function, is algebraic function. E power x is an exponential function. So based on the hierarchy rule, u has to be chosen as x square. So that is what I've done here. And what is the rest? The rest is e power x dx. So as per the formula, what are all the things that I have to calculate? I have to calculate u dash, u double dash, u triple dash. Then I have to calculate v1, v2, v3 and so on. So what I'm doing here is, in the left hand side, immediately after writing u, I am finding all the derivatives of u until I get a non-zero constant. So you find that u dash is 2x, u double dash is 2. On the right hand side, what I'm doing is, I'm going to integrate your v. How many times do you have to integrate? Based on the number of terms that you differentiate. So if you differentiate 2 times, here I have to integrate 3 times. If you're going to differentiate 3 times on the left hand side, I have to integrate 4 times on the right hand side. Only then you can apply the formula properly. So right hand side, since the function is only e power x, how many ever times I integrate, I'll be getting the same answer. So what is the formula? Integral of u dv is actually u into v. What is u into v? X square e power x minus u dash into v1 is 2 into x e power x plus u double dash v2 is 2 e power x plus c. So we have seen some of the main techniques for integration under indefinite integrals. What are they? They are the direct integration. Next is the integration by substitution. Then integration using partial fractions, integration by parts, and generalization of integration by parts, which is known as Bernoulli's formula. Now we enter into the other classification of integrals, which is known as definite integrals. Here we are going to limit ourselves to only some of the simple problems based on the properties of a definite integral. So already I have told you, a definite integral is the one where the integrals which is nothing but an integral with limits. Already it has been discussed. So you have some of the important and interesting properties of a definite integral. With the help of these properties, we can actually solve the problems in a very easy and a quick manner. So some of the properties that we have under the definite integral are, the first and the foremost one, integral a to b f of x dx is equal to integral a to b f of t dt. So what does it imply? As far as the functions are same, limits are same, the values are same, whether the variable is x or t or u or v. That is your first integral. The second one says integral a to b f of x dx is equal to minus integral b to a f of x, which means when I change the limits, I will get a negative sign. Then integral a to b f of x dx is equal to integral a to c plus integral c to b, which means I am splitting an interval into two subintervals. A and b, I am splitting it as a to c and c to b. And the fourth property I have bolded it very brightly because that is the most important property which we will be using very often in almost all the problems to solve the definite integral problems. So which is integral 0 to a f of x dx is integral 0 to a f of a minus x, which means I am changing x as a minus x, where a is the upper limit of the integral. Then of course you have the two more properties, which is integral minus a to a f of x dx. When the integral is of this form, you can write it as twice 0 to f of x dx if f of x is even. What do you mean by even? F of minus x equals f of x, and the integral value is 0 if f of x is odd. What do you mean by that? F of minus x is minus f of x. Similar to fifth property, you have one more property, integral 0 to 2a f of x dx is twice 0 to a. Again, this is the answer provided on condition is satisfied. What is that? F of 2a minus x is equal to f of x, and it is 0 if f of 2a minus x is minus f of x. And an important corollary to this property is integral 0 to pi f of sin x dx is equal to twice integral 0 to pi by 2 f of x, f of sin x dx. That is, whenever I have only function involving sin x, 0 to pi is twice 0 to pi by 2. So using these properties, we will see how we are going to solve the problems of the definite integral. So this is some of the standard problems. The first one is the integral 0 to pi by 2 log tan x dx. So what do you do here? As I told you, almost all the problems you will be using the property 4. What is that? Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So here also, before proving the property, we are letting the given integral as I. Then we are going to use the property integral 0 to a f of x dx is 0 to a f of a minus x dx. When you use that, what happens is your x is replaced by a minus x. Here a is pi by 2. So your log tan x becomes log tan of pi by 2 minus x, which is log of cot x dx. But integral 0 to pi by 2 log tan x dx and integral 0 to pi by 2 log cot x dx, they are almost similar. So this cannot also be integrated. But what can be done? Now, what is the beauty is that when you add the two equations, yes, equation 1 and equation 2, what happens is you will be getting 2i in the left hand side, whereas in the right hand side you will be getting it as integral 0 to pi by 2 log tan x plus integral 0 to pi by 2 log cot x, which is integral 0 to pi by 2 log of tan x into cot x. Using the property log m plus log n is log of mn. You will get log of tan x into cot x, and you know tan x into cot x is 1. So integral 0 to pi by 2 log 1 is 0 as log 1 is 0. So we have 2i equal to 0 or integral I is equal to 0. Therefore, integral 0 to pi by 2 log tan x dx is equal to 0. So function looks actually difficult function, but you are getting the answer very quickly and very easily when you use this beautiful property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. This is a similar problem to your first problem. 0 to pi by 2 sine power 3 by 2 x by sine power 3 by 2 plus x plus cos power 3 by 2 by x. So integrating a trigonometric function is difficult. That too with rational power is even more difficult. So when I use this property, you will be able to get the answer very quickly. So same as the previous problem, take the given integral as I, then use the property. When you use the property, sine of pi by 2 minus x becomes cos x. So your numerator alone changes, denominator remains the same. So like the previous problem, add the two integrals, you will be getting 2i equals simply integral 0 to pi by 2 1 dx, or 2i equals pi by 2, so I equals pi by 4, which means integral 0 to pi by 2 sine power 3 by 2x by sine power 3 by 2x plus cos power 3 by 2x dx is equal to pi by 4. So in fact, instead of 3 by 2, if the question is sine power half, in the sense root sine x by root sine x is root cos x, then also the answer is pi by 4. Instead of that, if you have the question as sine power nx by sine power x by plus cos power nx, then also your integral value is going to be the same as pi by 2. These are all part A questions. And this is one of the most important questions in part B, in the very standard question, which is integral 0 to pi by 2 log sin x dx. So as we have done in the previous problems, when we use the property, integral log sin x becomes integral log cos x. So I cannot do anything with this integral as such. So same way, add the two integrals, we will be getting 2i equals log of sin x into cos x, which can be written as log sin 2x by 2, which can be written as log sin 2x minus log 2. Now, when you look at the integral in equation 2, you find that the second integral on the right hand side can be integrated easily because log 2 is a constant. But look at the first integral. What is the first integral? It is integral 0 to pi by 2 log sin 2x. So it is actually similar to your original integral log sin x. Only difference here is instead of x, I am having 2x. So what you should do is you have to change that 2x to x. So this can be achieved only through substitution. So what is the substitution you make? Put 2x as t. Therefore, 2 dx is dt. Once you make a substitution, since we have limits here, I have to change the limits also. When x is 0, t becomes 0. When x is pi by 2, your t becomes pi. So integral 0 to pi by 2 log sin 2x dx becomes half integral 0 to pi log sin t dt. But 0 to pi log sin t dt is of the form 0 to pi f of sin x dx. So which can be written as twice integral 0 to pi by 2 f of sin x. So therefore, we have here as it is equal to twice 0 to pi. So you'll be getting it as integral 0 to pi by 2 log sin t dt, which means you get 2i equals I minus pi by 2 log 2, or I is equal to minus pi by 2 log 2. Okay. So what we have seen so far is whenever you are given any integral, see whether you can do it by a direct substitution. If not, there is direct integration. If not, try for substitution. If not, try for partial fractions. Otherwise, you can try for integration by parts. That is in the case of indifferent integrals. Definite integrals, make use of the properties and try to solve the problems. So these are the problems for practice which you can try, and then the answers are being given to you also. Just try these problems. So look at the function carefully and see what type it fits into and try to solve it accordingly. So in the tomorrow's session, you'll be having your second unit, unit 2, whereas the differential calculus will be taken care of as staff member. So thank you, students. Make use of this